Welcome to the deep dive. Today, we're looking at something critical for military readiness, specifically the U.S. Space Force's big plan to build its next-gen space test and training infrastructure.
That's right. This is a major strategic effort. We're digging into this really significant contract vehicle from the Space Systems Command, the SSC. It's all aimed at the National Space Test and Training Complex, or NSTTC.
NSTTC sounds like, a building somewhere, but looking through the documents, it seems much bigger than that. The contract itself is called NITE-STAR. What's the core mission here?
Yeah, NITE-STAR is the contract name, the Capability Development IDIQ. The real driver behind it is the OTTIIPO. That's the Operational Test and Training Infrastructure Integrated Program Office.
Okay, OTTIIPO. And their goal?
It's not just about replacing old gear. It's about fundamentally changing how the Space Force trains. They need interconnected, scalable systems and distributed ones, too.
That's key, isn't it? Not just one place.
Exactly. We're talking live, physical ranges, actual satellites, ground gear, and these really advanced synthetic digital environments. The whole point is to get USSF warfighters ready to, prevail in contested space.
Mm-hmm.
This is foundational stuff.
Okay, so building the foundation for future space conflict readiness, let's unpack what that actually means they need to build. The statement of work, it covers hardware and digital simulations, right?
It's definitely dual-pronged. On the hardware side, they need contractors who can deliver space-based test and training systems. So think satellite vehicles, the subsystems, payloads like sensors, comms, relays, all designed for training and testing.
And you can't have space assets without ground support.
Absolutely. That's the other big hardware piece. Ground-based test and training systems. So ground stations, advanced sensors, antennas, telescopes, radars, and a really robust command and control, or C2 setup. It all has to work together for live, virtual, and constructive LVC training.
Right. Now, the part that feels really different from maybe past efforts, the deep focus on digital systems. It's not just simulation after the fact.
That's the big shift, yeah. They're not just asking for simulators. They want, like, a whole synthetic test range.
Mm-hmm.
The solicitation explicitly calls for hardware-in-the-loop, HYL, and software-in-the-loop, SYL.
HWYL, for listeners, why is that such a significant requirement? What makes it hard?
Well, HYL is tough because you need specialized facilities. You're taking actual flight hardware, maybe a navigation unit or a critical sensor, and plugging it into a digital simulation that mimics, say, a hostile space environment in real time.
So you're testing the real thing against a virtual threat.
Exactly. It lets them validate performance way before launch. And honestly, only the big players, the primes with those existing high-fidelity labs can really do that effectively. It's a huge barrier to entry.
And underpinning all this digital work is the idea of the digital twin. How's the Space Force applying that here? Is it just a buzzword, or is it really changing things?
Oh, it's critical. They're requiring contractors to deliver these dynamic, real-time digital twins of the actual space and ground systems being built. It's not static. It's used constantly for validation, predicting performance, optimizing things.
Even before launch.
Yes. And crucially, these twins also power adaptive training environments for the operators. So if the real system works well, the twin in the simulation does too. If there's a problem, the twin reflects that problem. Makes the training incredibly realistic.
Hyper-realistic. And they're not cutting corners on how this digital stuff gets built either, are they?
No, definitely not. The solicitation is very clear. You need to use modern digital engineering tools, model-based systems engineering, MBSE. You need DevSecOps for security and speed, and stick to modular open systems architectures, MOSA.
So they want systems that are future-proof, easy to upgrade, not locked into one vendor.
That's the idea.
Yeah.
Avoid vendor lock. Allow for rapid updates. They want agility.
Okay, so we've got groundbreaking tech, demanding digital skills. Let's shift gears to the business side. How do you manage and pay for something this big? Potentially over a decade. What's the contract structure?
It's definitely a long-term play by the Space Force. The IDIQ itself has a 5-year base ordering period, plus a 5-year option. So potentially 10 years of ordering.
10 years. And the actual work, the projects?
The individual task orders, or TOs, they can actually run for up to a year beyond the end of that final ordering period. So if the option is exercised, we can see work going on under NITE-STAR well into, 2037.
Wow, 2037. That allows for some really significant long-term development.
Mm-hmm. And the financial flexibility reflects the complexity, too. They haven't just picked one contract type for the task orders.
Right, I saw that. Why offer so many different types?
Well, think about it. They're building known things like ground stations, but also brand new synthetic environments. The risk levels are totally different, so they need different tools.
Makes sense.
Yeah, so you see firm fixed price, FFP, for stuff that's well-defined. Then for the riskier development, maybe cost plus fixed fee, CPFF, or cost plus incentive fee, CPIF. And they've got award fee types like FPIF, CPIF, FPAF to incentivize performance.
That flexibility is probably key to getting good competition across different types of tasks.
Absolutely. It's a smart government strategy.
Given all that, what's the financial scale we're talking about? Is there a maximum value for a single order?
There is, and it's substantial. The Order Limitations Clause sets the maximum for a single item or a combination at $981,000.
$981 million, so almost $1 billion for potentially one order. That's massive.
It tells you they're planning for major system integration and deployment under this contract, not just little upgrades. They expect to need large-scale capabilities probably quickly.
It screams national-level infrastructure build-out.
That's exactly what it is.
Okay, that's the money side. But getting to the point where you can even bid on one of those big task orders, there's this incredibly tough technical screening process, right? Like a series of gates.
Yeah, it's a gated evaluation. Miss one requirement, and you're out. It's designed to filter for companies already operating at the absolute highest levels of national security space.
Gate 1 is security, right? Pass-fail.
Correct. Gate 1, security compliance. It's blunt. At the time you submit your proposal, you must have a minimum facility clearance level FCL of top secret.
Okay, top secret.
And it needs a special access program facility, SAPF overlay. Plus, that whole setup needs to be accredited for handling work up to TSSCI and SARSAP levels.
Whoa, okay, TS is one thing, but that SAPF overlay, that really narrows the field, doesn't it? That's basically the big established primes who are already deep in classified government work.
It's an immediate filter. If you don't have that FCL with the SAPF overlay right now, you cannot compete, period. They also need proof you can handle cybersecurity and the risk management framework RMF according to NIST standards. That's non-negotiable.
Okay, hurdle 1 cleared. If you make it past that, you hit subfactor 2. Qualifying relevant projects, QRPs. This is about proving you've actually done this kind of work before, right? As the prime contractor.
Exactly. And not just any work. It has to be recent, at least 6 months of performance within the last 5 years. And crucially, like you said, you had to be the prime contractor for the U.S. government. Subcontractor experience doesn't count here.
They want prime leadership experience. So what are the specifics? QRP1.
QRP1 is all about low Earth orbit, LEO.
Yeah.
You need to show a project where you did the whole lifecycle development, integration, testing, launch support, on-orbit checkout for a LEO system.
And it has to meet certain specs.
Yep. Operated at or below 2,000 kilometers altitude, single satellite mass of 100 kilograms or more, and a design life of at least 1 year.
Okay, so proving capability in that busy LEO environment, then QRP2 jumps way out to GEO.
Right. Completely different regime. QRP2 is geosynchronous or geostationary orbit, GEO. Same development steps required, but for a GEO system. And the thresholds are higher.
How much higher?
Single vehicle mass has to be 500 kilograms or more, much heavier. Design life of at least 3 years. And, specifically, you must have demonstrated secure ground telemetry, tracking and commanding TT&C.
So LEO and GEO prime experience, why demand both? Doesn't that squeeze out companies that might specialize in just one?
Oh, absolutely it does, and that's likely intentional. The Space Force needs integrators who understand the challenges of both fast-paced, maybe lower-cost LEO, and the super secure, long-duration, high-value GEO environment.
Because the training complex has to cover both.
Exactly. To simulate and test across the whole potential battlefield, you need companies that have proven recent prime experience in both. It really limits the field to maybe a handful of players. True full-spectrum capability is the requirement.
So that's a very exclusive table.
Yeah.
Okay, let's say a company wins, they get through the gates. Who supports the government in overseeing this complex work? There are non-government advisors, NGAs involved.
Yeah, the government team relies heavily on NGAs. The documents list the usual categories: FFRDCs, federally funded research and development centers, URCs, university-affiliated research centers, and ANAS advisory and assistance services contractors.
Any specific names mentioned? Who's already in this ecosystem?
Sure. For FFRDCs, they list the Aerospace Corporation, MAN-IRE, MIT Lincoln Labs. URCs include places like Johns Hopkins Applied Physics Lab, JOG, UAPL, Utah State's Space Dynamics Lab, SDL. And for ANAS contractors supporting SSC, you see names like Galapagos Federal Systems, SAI, GDIT, ManTech, among others.
Okay, which brings us right to organizational conflict of interest, OCI. If those ANAS firms are advising the government, who can't bid on NITE-STAR itself?
This is a really important rule they've put in place. Basically, if your company is currently providing ANAS, or Set of Systems Engineering and Technical Assistance, or FFRDC support directly to the OTTI program office, you are precluded from bidding on NITE-STAR.
So you can't help write the rules and judge the game if you also want to play in it.
That's the gist. Avoids conflicts, maintains objectivity. It's pretty standard, but very explicitly stated here.
But once a prime contractor wins NITE-STAR, they do have to work closely with some of these advisors, particularly the FFRDCs, right? Even with the OCI firewall during bidding.
Yes, the dynamic shifts post-award. The winners must cooperate with certain FFRDCs.
How deep does that cooperation go? Are we talking about sharing sensitive company information?
Extremely deep, especially with the Aerospace Corporation, because they handle a lot of the General Systems Engineering and Integration, GSE&I, for Space Systems Command. The prime has to attend meetings, grant access to their facilities.
Okay.
And here's the big one. They must provide aerospace access to technical information, research data, and yes, even proprietary data.
Yeah.
Things like design details, test results, cost data. And they have to let aerospace personnel observe technical work.
Wow. Handing over proprietary design data, that shows how tightly the government wants to manage this. The stakes are just too high for a typical arm's-length relationship.
Pretty much. It's about ensuring national security needs are met, even if it puts a significant burden on the contractor regarding their intellectual property.
Okay, let's wrap up with the very first step. You get through the gates, you win the award, you navigate the OCI rules. What's the absolute first thing that happens? Task Order 1.
Yeah, Task Order 01. It's the post-award kickoff conference. It's mandatory. It's issued to every single winner immediately upon contract award, and it actually satisfies the minimum order guarantee for the whole IDIQ.
So kind of like the official welcome handshake. What's it worth?
It's a firm fixed price task order valued at exactly $10,000.
10 grand. And what do they do for that?
It's basically a 90-minute meeting, face-to-face, in Colorado Springs within 30 days of the award. The contractor introduces their team, shows an org chart with roles, and gives a quick overview of their capabilities and how they plan to tackle future task orders. It's the formal entry point.
So, to sum up, NITE-STAR is this massive, truly generational step for the USSF. It demands contractors with incredibly high security clearances, deep digital engineering skills, and that proven prime experience in both LEO and GEO. It's an extremely high bar.
It really is. And I think the biggest takeaway maybe is that digital transformation. They're not just buying hardware. They're building these complex synthetic digital ranges using MBSE digital twins, all geared towards highly realistic adaptive training and testing.
Which leads to a final thought. Since they're demanding this mastery of both LEO and GEO, two very different domains, how much seamless integration will the Space Force eventually require between those digital twins and training environments? Could the future of space readiness depend on flawlessly connecting simulations of vast LEO networks with those resilient GEO assets? Something for you to think about.